Alright, so we've been working systems of equations. Today we're systems of inequalities. Now we've worked with linear inequalities, so just look at something like this. Y less than negative x plus 3. Remember, we would just graph this. It's a line. There's not an equals there, so it'd be a dotted line. And then remember, you have to shade one side or the other. It's less, so in this case it'd be below. But if you're not sure, remember you can always test a point and see what happens. Of course, we can graph these on Desmos.com as well, and I would really encourage you to do that. Powerful, powerful tool. I hope you're taking advantage of that. So just like system of equations is a set of two or more equations, system of inequalities, set of two or more inequalities. What is the solution of a system of inequalities where it's where their shaded regions overlap? And so a system of equations, right, they maybe cross one place. Well, in these, because you have shaded regions, you could have a lot of solutions that would be true, and it's going to be that shaded region. So how do you graph these? I already kind of talked about it. Graph each inequality. Remember, is it solid line or is it dotted, depending on what the inequality says. If you're doing these by hand, I would say lightly shade the proper side of each inequality, because what we're looking for is where do the inequalities, where do they overlap, those shaded regions. And that shaded region you want to darken, and that would actually be the solution set. Now let me just look at a couple questions, types of things you'll see on a practice assignment today, okay? And so something like this. To verify an ordered pair as a solution, substitute the values in and just see that they're true statements. So here's an example question. The ordered pair -1, 5, okay, right here's where I'm looking, is a solution of which system? Well, how would you tell? I guess you could go graph all those and see which one had that point in the shaded, but that'd be kind of a pain. Let's just substitute it in. To be a solution, it has to be true in both equations, okay? So this is my x, this is my y, so let's just try it. So 5, if I put a -1 here, 5 is greater than -2. Hey, that's true, right? So far so good. 5 is greater than or equal to, let's see, -2 plus 10. No, that'd be 8. 5 is greater than 8. Not true. Hey, this one doesn't work. Well, just keep going. 5 is greater than 2. Well, that's true. 5 is less than 8. Less than or equal to 8. Hey, that's true. I'm liking this one. In fact, I feel like that's the answer, but let's just check the other two real quick. 5 is less than 2. Doesn't work. 5 is less than or equal to 2. Well, it doesn't work either. So just substitute in and check. Not too bad, okay? How about something like this? Which graph is the solution of the system? Which graph is the solution of the system? Now, a couple things we can look for. Okay, notice these lines all look the same, so they're not showing us a bunch of totally different looking graphs. In fact, in this example, they even show you the equations on the graph. They may not do that all the time. So let's look at a couple things. Less than or equal, greater than or equal. Both lines have to be solid, don't they? So I can automatically get rid of that one. Now, less than or equal to, in fact, let's do this one first. Greater than or equal to -x. So here's my -x line. Greater than or equal, well, that would be above that line. So that would be this side. Both of those are shaded above it looks like. So both of those are okay so far. Less than 4x plus 2. So that's this line, right, going up. Less than. Well, this is above, so over here would be greater. So it looks like it's got to be this side to me. And so it looks like it should be down here. So the overlap, again, looks like this region. And so I like letter A right here. Okay, and again, you could choose a point out here, test it in both of them, see if it would work. Let me show you something else though. No reason to miss a question like this ever. Desmos.com, right? Worst case, you could go graph it. So I've already typed them in here just to show you. So there's the two equations. And let me click over here. So here's the first one. Notice it's shaded below, like I mentioned. And here's the second one, shaded above. The solution is the overlap. Okay, I wish they would just wipe that out, but they're showing these two. So you need to see where do they overlap. And notice it's this region, just like we said right here, right? It's that region. So again, I just want to illustrate, worst case, go graph these on Desmos.com and see what it looks like. Awesome tool. Okay, one more type problem let's look at. What if you deal with like absolute value in lines? It doesn't matter, okay? Which system is the solution? So they give us a graph and they want us to decide, well, what's the system? We're actually going backwards. Now I want you to notice something. Again, the equations are all the same. So they're not trying to trick you by throwing a bunch of different crazy equations at you. They really want you to look at these symbols. So let's identify something. Here's my absolute value, right? Little V-shaped. Notice it's a dotted line. So its inequality cannot have equals. Well, none of those do. Okay. This line is solid, so it has to have the equals in it. This one doesn't. Automatically I can rule it out. Those all have the equals. Okay, so let's see what we're up against. So it looks like it's above this line, so that would have to be greater than or equal, right? It's shaded here above it. So greater than or equal, well that one's not. This one is, okay. And for my absolute value, it's below it, right? It's under it. And so that would have to be a less than. Hey, there you go. See how I kind of piece my way through that? Again, worst case, it'd take longer, but I guess you could go graph each of these on Desmos and see which one matched. But honestly, I would hope you can kind of think your way through it, just like I did. Kind of look at the clues that they give you, okay? So that's graphing systems of inequalities. The lesson's going to have a couple, real life examples. They'll just give you some word problems. You'll kind of build and look at some examples. I think they're pretty straightforward. So think your way through things. As always, if you have questions, please don't hesitate. Reach out. Hope you have a great lesson.